Welcome to Math 1314. We are looking at section 1.7, continuing our discussion of absolute value. Before we do that, we need to look at number lines, graphing, and interval notation. So here in the very first one here, I want all numbers greater than or equal to 2. Notice there is a closed dot because 2 is included, and this goes off to the right forever. The closed dot gives you a bracket. Going to the right forever is infinity. So with interval notation, you put the smaller item on the left, larger item on the right. Here, what if I want all numbers smaller than 3? There's a open dot there because 3 is not smaller than itself, but 2.99999 is. And so we put an open dot just to represent we can get as close as we like to 3, just not exactly 3. Left forever is minus infinity up to 3. A open dot gives me a parenthesis. What if I want all numbers that are in between 2 and 7? Notice the 2 has no equal, so that's a open dot. The 7 does have an equal, that's a closed dot, and I want all the numbers stuck in the middle. Open dot gives me parenthesis, closed dot gives me this bracket. In this last one, let's see. 5 greater than or equal to x. Okay, well 5 does have an equal, so that's there. Now the pointy side is pointing to the right. Does that mean I shade to the right? Let's see. If I pick 6, is 5 greater than or equal to 6? No. What if I pick 4? Is 5 greater than or equal to 4? The answer is yes. So the way I would shade would be off to the left forever. If I've got the whole number line, all numbers x, everything is shaded, and we write that as minus infinity to infinity. Sometimes again, you see this written as a R with these two lines. So just to put it together, if I've got one of these two inequalities, that's going to be a closed dot and some kind of a bracket. If I've got one of these inequalities, no equal, I'm going to have a open dot and parentheses. In math, we often use the words and or. And means intersection, or find what's in common between two sets. And we write intersection with this flipped over U. Or stands for union. Union is I put everything together. I dump it all in one box. And when I do that, I just don't put in any repeats. All right, so putting it all together, we use this upward looking U for union. So and is find what's in common, or is put it all together. So in question 1, they say graph all the x's that are bigger than minus 9. Okay, no equal, so I've got a open dot. Bigger than minus 9 goes to the right forever. What about this? X smaller than 9. Okay, here's 9 and everything smaller. And then I see this word. That means I need to find out what is in common between these two things. Well, let's see. All of this stuff in here is in common, all the way up to minus 9 and 9, which I can write in interval notation that way. What about question 2? Question 2, let's see. I want all the x's smaller than minus 5. Oh, there's an equal. All right, that's going to be a closed-in dot and off to the left forever. I've got all the x's greater than or equal to 5. Again, a closed dot. Going to the right forever. And then I see this word in the middle. The OR stands for union. And what that means is put everything together. So I grab the stuff on the left. I grab all that stuff. It's all together. This stuff on the left is minus infinity to minus 5 with a bracket. This stuff is 5 to infinity with a bracket. Remember, infinities always get parentheses. Question 3. Question 3 says solve these two problems and then OR them. Okay, well, let's see. If I do the one on the left, if I move this minus 2, it's a plus 2. 2 minus 8 is a minus 6. And then I divide both sides by 2. And I get all the stuff less than minus 3. Open dot, because no equal. And then I got the other piece. Let's see. I move the 2 again. 8 and 2 is 10. Divide both sides by 2. 10 divided by 2 is 5. And so I want all the things bigger than 5, no equal, open dot. Since it's an OR, I want both parts. So I've got the left part, the right part, and my U for union because I've got multiple pieces. All right, what about question 4 here? Question 4 says, I've got two things again, and I want to use AND. Remember, AND was what's in common. All right, so let's see. I'm going to move the 1, so minus 8 minus 1, that's a minus 9. I need to get x by itself, so divide both sides by 3. And so I've got all the x's greater than or equal to minus 3. All right, so there it is. It goes to the right forever. Close dot. They might say, well, whoa, what happened? You rewrote this in a different way. Yes, but notice the pointy side is pointing at the minus 3. And so if I want to write it in the other way, as long as things are still pointing where they need to be, we're in good shape. All right, what about the other part? Minus 1, 8 minus 1 is 7. Divide both sides by 3. And so I get all the stuff less than or equal to 7/3. But I have an AND, so what's in common between this stuff and that stuff? Well, all the stuff here in the middle, all the way up to minus 3 and 7/3. All right, some things to remember about inequalities. For example, 2 is less than 3, but if I multiply or divide both sides by a negative, the inequality must flip around to remain true. You can add and subtract negatives, and that will not change the inequality. But if you multiply or divide by a negative, it flips the inequality around. All right, so let's see here on question 5. Let's see. First one, absolute value of k is equal to minus 12. Now, that can never happen because remember the absolute value is either 0 or positive. It is never negative. So, no solution. B, absolute value is bigger than minus 12. Well, when could that happen? What numbers could I put in there to make this true? But if you remember, the absolute value of k is one of two things, 0 or positive. And so if the thing on the left is 0 or positive, it's always going to be bigger than minus 12. And so the solution is all real numbers. What about C? Again, the same reasoning. This thing on the left can only give me a 0 or a positive. And could a 0 or a positive ever be smaller than minus 12? The answer is never, and so there is no solution. All right, question 6. Let's see. Absolute value, w minus 1 equals 7. Okay, I remember when it's equal, I simply grab the inside and I make it equal to plus or minus the number. And so I do that, and then I use the plus, and then I use the minus. And so I get minus 6 and 8. All right, on the next one, let's see. Absolute value, w minus 1 bigger than 7. Notice the inequality points away from the absolute value. When that happens, you must make two separate problems. The first one is exactly like it's written, just does not have absolute value. And so if I move this minus 1, I got 1 plus 7. And so I get all the w's bigger than 8. In my second one, I have the exact same inside. Two changes. Inequality points the other way, and I've got the negative of the number. So I move the 1 again. 1 minus 7 is minus 6. And so I get all of the stuff less than minus 6. This is a OR situation. So it's a union, so I put both of them together, and there is the union that connects them. Notice when the inequality points away, my answer looks away. All right, what about here? When I've got absolute value and the inequality points toward the absolute value, I trap the middle in between the number and its negative. Again, the direction of the pointy part matters. If it looks away, two separate problems. If it looks toward, I trap it in the middle. I then work on all three parts. I want to isolate W. 7 and 1 is 8, minus 7 and 1 is minus 6, and I get all the stuff in the middle. They are open dots because I don't have any equal, and so I get parentheses on the two sides. All right, let's see. Question 7. All right, the very first one here. Absolute value of something equals minus 5. No, that can never happen. Doesn't matter what you put here. The absolute value is always 0 or positive. Absolute value here bigger than minus 5. Yeah, sure. That always works because regardless of what goes in there, the absolute value is always 0 or positive. And the last one here, absolute value smaller than minus 5. No, that can never happen. This thing on the left is only 0 or positive. Let's see, question 8 here. Well, it looks like first I need to clean things up. So I'm going to move the plus 10. So that's 15 minus 10, and I get a 5. Oh, inequality is pointing at the absolute value. So I turn it into the trapped kind. I want to isolate the y, so I work on all three parts. I subtract 7 and I get minus 4, a 4y, and a minus 2. I don't quite have y by itself yet, so I'm going to divide everything by 4. Minus 12 over 4 is minus 3. Minus 2 over 4 is minus a half. No equals, so open dots. And when I write it in interval notation, I've got parentheses. Question 9. Let's see, looking at 9 here, again, I need to clean things up. So I'm going to move the 5. So that's 11 plus 5. That's where the 16 came from. It points away with the inequality. So I've got two separate problems. So let's see. If I move the 8, that's 16 minus 8 is 8. I don't have t alone. It's a minus t, not just plain old t. And so to get rid of that minus, I'm either going to have to divide by minus 1 or multiply by 1. In either case, as soon as I do that, notice the inequality turns around. And so for the first part of my answer, I get all the t's smaller than minus 8. See, there it is there. Bracket because of the closed dot. My second version, remember there were two versions because it points away. And I have to have two changes. Here's the first. Inequality is turned away. And here I've got the negative of the number. All right, I need to get t alone, so move the 8, minus 16, minus 8, so a minus 24. I need to get the t alone. I divide both sides by a negative, but the inequality flips around. Let's see, questions 10 and 11. Absolute value of this thing smaller than minus 3. No, that can never happen because, again, this thing on the left, whatever number you plug in, the only thing it can give me is 0 or a positive. It can never calculate to be smaller than minus 3, and so we get no solution. Question 11 here. Let's see. Absolute value less than 4. Okay, pointy part is pointing toward, so trap it in the middle in between the number and its negative. I want to get the y part alone, so let's see, what will I do? I need to get rid of that 2. Well, to get rid of it, I need to multiply all the way through by 2. And when I do that, these 2's would cancel. I will get the middle. I get a minus 8 and an 8. I need to get rid of this minus 5, so I add 5. Minus 8 plus 5 is minus 3. 8 and 5 is 13. No equals, so open dots. And I've got minus 3 to 13. All right, let's see. Question 12. Question 12, we have a real world problem here. We have the length of a board, and the board is measured to be 31.5 inches. Every measuring device always has a measurement error, whether it's length or weight or volume. It has a measurement error, and here it's plus or minus 0.2 inches. So what that means is with the error, the length could really be 31.5 plus that number, or it could be 31.5 minus that number. Which means here is my 31.5, which I think I measured, but the real measurement could be down by 0.2 or up by 0.2. So what that's really saying in absolute value is the distance between x and that number is less than or equal to 0.2. And so the solution is the measurement could be anywhere in between 31.3 and 31.7. So a real world application of absolute value. All right, remember, stop the video. If you get lost somewhere, go back, rewind, listen again, think about it, and try more.